Hello, we are Alberto, Ninos, and Amaya, and today we are going to present to you our algebra presentation. We first did a survey on our students to see how they commuted from their houses to university, which transportation they used, and we saw that the three main ones were the bus, the bicycle, and walking, but there were also the car and skateboards. And so we first took the three most used ones, and we did with Markov's chain, we did the solutions. Okay, so in the moment 0, these are the data we had, and then we did a campaign to promote a healthy lifestyle, and so we saw that, well, then after this campaign was promoted, we saw that people would tend to use more healthy transportations to go to university, and so we saw how it changed.
We divided our project by 4 steps. First, we wrote down the transition matrix, then we calculated what would happen after 2 months, and we also calculated the equilibrium, and lastly, we predicted the distribution after some months.
After the University of Nevada made a campaign promoting exercise, this data was collected. 80% of each one stayed loyal to the way they went to the university, and the other 20% changed equity to other ways. So basically, the people who used to go by bus, 20% changed to the other ways. However, the people who used to go by bike or walking, they changed but not to going by bus. In order to calculate how many people would go by bus, bike, walking the first month and the second month, first of all, we have to multiply the transition matrix with the data of today, and we get those results. And for the second month, we have to multiply the transition matrix with the data we got there, and we get that new data. Okay, what we can see here is that each month less and less people go by bus, and walking and bike tend to increase. Okay, in order to calculate the equilibrium, we have to first of all keep in mind we have to add x plus y plus z equals to 1. So that would mean adding a line of 1s to the matrix. We as well have to subtract 1. So after doing this and doing all these different operations in different matrices, we get these equations. We solve this equation and we get that y is equals to a half, z as well is equals to a half, and x is equals to 0. So basically what this means is at the end the equilibrium is reached when no people goes by bus, and then half of the people goes walking and the other half goes by bike.
By using Markov's chain rule method and calculating for 10 months, we got this matrix and its eigenvalues and its eigenvectors.
Okay, so after seeing how these 3 transportations change over months, we now took the 5 transportations we talked about earlier and put them in maxima to solve it. So this is the transition matrix we've got with the 5 main transportations, and then these are the 3 eigenvalues and its corresponding algebraic multiplicity. And so then we just did the eigenvectors, which are these. So here we've got the 3 eigenvalues with their algebraic multiplicities, and the 1 eigenvector for this, the eigenvector for this, the other one for the 3rd eigenvalue, and here 1 and 2 eigenvectors for the last eigenvalue. Okay. So then we just did we put a D matrix, then the P matrix, and we inverted P just to calculate what in the after n months what would happen. And And we also wanted to know what the equilibrium would be. So we took this, which is one of the eigenvectors, and we sum it. So we saw this one was, the result was 2, so we now know that in the equilibrium, these are this is the value that it would take. We also did the equilibrium with another method, and we took, well, we had this result, and so we see here there's an n, and in the infinite, this would go, and so this matrix we would have this matrix which would sum 1, and so this would be equilibrium. Numerically, this is the result we obtained in equilibrium.